Welcome, everybody, and thank you for joining our presentation today. My name is Heather, and I'm part of the marketing team here at Eagle Eye Networks. Today's topic is installing cameras for operational efficiencies. If you have any questions throughout the presentation, please type them in the Q&A box in Zoom, and we'll discuss during our Q&A session at the end of the presentation. Now I will go ahead and introduce our speaker for today. We have Matt Webster from our sales engineering team. Matt has had 10 years of physical security industry experience, including sales, engineering, and product management roles for both integrators and manufacturers. He specializes in CCTV design and deployment for enterprise scope applications. He's going to cover a lot of really great information for you all today. So with that, I'll go ahead and pass it along to Matt.
Hey, good morning, everyone, and thank you very much for the introduction. I do appreciate it. Like Heather said, my name is Matt Webster. I am one of the sales engineers here at Eagle Eye. I am sort of the resident camera guru as well, as we like to call it. And we're going to be giving you a presentation, sort of a general presentation on what to think about when you're picking surveillance applications, cameras, hardwares, strategies, things of that nature. So hopefully it'll be informative and entertaining. I'm going to try to keep this to less than 30 minutes. We've been timing it. I'm going over just slightly. So hopefully I can confine it within that time. And without any further ado, I'm going to go ahead and start. Eagle Eye Networks, we are the #1 cloud VMS solutions provider in the world. We were founded by a gentleman named Dean Draco. He was also the founder and CEO of Barracuda Networks. We've been in business for over 8 years, and we are headquartered in Austin, Texas, so the sort of tech capital of the Southwest. And we have global offices in Tokyo, Amsterdam, and Colombia, and we operate in over 80 countries. Just real quick for some housekeeping, we're going to go over this agenda here. Like I said, we're going to go over what to think about as far as cameras, the traits of those cameras, those form factors, different types of performance specifications that are going to help us accomplish what we want to do. We're also going to go over sort of a newer technology that we're actually in the process of releasing at the very end of this month on April 30th. It is a fisheye dewarping technology. Essentially, a fisheye is a special type of camera that uses a special type of lensing technology to produce a field of view that is very wide. It's actually 360 degrees. And we've built some sort of special sauce into our web-based VMS platform that allows us to leverage not only the higher resolution this camera is capable of, but being able to essentially spool up multiple fields of view from the same stream. We refer to this as fisheye dewarping. Those of you that are familiar with CCTV systems have probably seen this before. This is our first implementation. And what's interesting about this is all within a web interface. And we sort of have a unique way that we've done it and a unique pricing model associated with it. We're going to go over, again, the specific hardware limitations and performance indicators that we need to consider when we're going to be deploying a CCTV system. We're going to go over the strategy itself. There are general strategies when designing a deployment. And then there's also going to be some specialized information we're going to want to know. Typically, that's going to come from you, the customer. When it comes to things that a general strategy might not cover. So we're gonna go in how you, the customer, can assist your dealer, your integrator, the person who will be installing and managing the CCTV system to create a greater overall effective application. We're going to talk about the platform a little bit as far as our cloud VMS, certain benefits of using it, and how we can design a solution that is both powerful but cost effective. And then at the end, we're going to touch upon analytics. Analytics, we're gaining data from the video streams that we are recording. Analytics allows us to essentially process that data within on the premise, so via a computer, and we can essentially produce notifications, alerts driven off these analytics. So we're going to get into how we can use this type of technology and make just a normal security camera into a force multiplied provide assets to, mitigate not just crime, but also, internal things like mitigating slip and falls, accidental, theft or fights and things of that nature. So let's go ahead and let's get it kicked off here. So the first thing we want to discuss is going to be just camera types in general. I've been doing this so long that it's become a habit for me that when I go out into the wild, which I haven't done in a while, but when I go to businesses, I have a habit of looking to see if they have security cameras and what those are, where they're placed, what they're looking at. And sort of figuring out where they don't have coverage too. It's a weird, I've become a security camera nerd, for lack of a better term. But the vast majority of cameras you see out in the wild are going to be dome cameras. This is sort of the ubiquitous form factor that has been in the industry for a long time. There's also a form factor. It's this bullet style form factor. I would say, physically from a just a mounting or a deployment perspective, domes, again, they're used, pretty much primarily, but typically, when you're talking about deploying a CCTV system, you want to think of it in terms of the field of view or what you're going to be viewing at. Domes can be limited in the way that they can be mounted and the way that field of view can be configured. So essentially, if we want to maximize the application of a security camera, we need to take mounting hardware considerations to make sure that we are maximizing that field of view and therefore the potential to capture, what we're looking at. Whereas a bullet actually has more or less an adjustable arm mechanism. It has this sort of clutching mechanism that allows you to do fine tuning, but it essentially has the mounting hardware what the mounting hardware does is it gives you a better sort of attack angle. It's already built into the camera body itself. So it's going to be a little bit more versatile and simpler to deploy simply because we don't have to bother with putting together a dome camera with a wall arm and perhaps a pendant. And so there's obviously benefits between the two from a performance aspect. The one big differentiator is, I guess, technically speaking, the bullet would have better IR performance. So just to touch on that, all cameras nowadays, the vast majority of them will be, have IRs or infrared illuminators on board of the camera. This allows you to operate in a no light scenario. So, and just to not to deviate too much, but understanding the difference between no light scenarios and low light scenarios is going to be very important. We're going to cover this idea of low light color reproduction capabilities within cameras. But for this use case or what we're talking about right now, the IR gives you the ability to operate in a completely no light situations. The IR actually provide the illumination. Essentially what it does is these illuminators will bathe whatever it's looking at with IRs, which then reflect off those surfaces, objects back into the camera, producing essentially a black and white image. And we're going to go, why that can be useful, but why that also from a forensic perspective, it can not be useful, right? So, but anyways, the IRs, both bullets and domes have IRs. The interesting thing about the dome is that the IRs are technically housed within the same area that the lens is, right? And so, you can run into situations where IR can bleed into the polycarbonate dome, right, back into the lens, and it causes sort of a flooding or a washing out effect. A lot of cameras nowadays have mitigated this. They've actually put essentially an opaque median between the lens and those IRs, and so it prevents from the IR bleeding in there. But older cameras, they can suffer from this. But it's not too big of a deal now with modern cameras. Whereas the bullet, essentially the IRs and the lens, they're separated, and they are, by design, they are separated by this opaque median. So the bullet can potentially have better IR performance, and bullets also tend to have better native environmental ratings. And again, this is just by the design of the bullet. You can typically positively pressurize the interior of these bodies, the camera bodies themselves, because the bullet, the dome, when you're trying to configure it, you actually have to take the housing off. So if you were to put pressure in there, you take the housing off, it's, that pressure goes away. But since the bullet, you don't ever really go inside that camera, from the manufacturer, they can actually pressurize these things and I'll go into it a little bit more, but I've actually installed some of these cameras like in Louisiana where during the floods, the cameras were completely submerged for a week at a time, and we were able to record like fishes going by it. So you might have some different environmental capabilities when choosing a bullet. The other two cameras, we have a PTZ and the Fisheye. The PTZ is, it stands for pan tilt zoom. This is a camera that requires operator interdiction, right? It's driven by an operator where the fields of view are going to be. There's essentially little micromotors within the body of the camera, and it allows you to reorient the field of view. Something to consider is these cameras are typically more expensive, and if you're not going to have an operator using it, you're sort of losing a lot of that value. So if you're going to deploy a PTZ, it obviously has a lot of functionality as far as being able to reorient the field of view and zoom in and gain better detail. But if you don't have anyone using it, it's essentially just a fixed camera. So just, if we're going to think about deploying that, let's just make sure that we are, taking that into consideration. And then of course the fisheye, I touched upon this earlier. The fisheye is the technology that it uses. It essentially uses this thing called it's an aspherical lens, sort of a teardrop lens, and it's able to gather light from 360 degrees around it, and it can actually bend light at a 90-degree angle. And what this ends up doing is it produces a view. It's actually a circular view, and the edges of that view are going to be warped, right? And so the rate in which that gets warped is known as the azimuth. It's sort of the rate of change of warping as you get to the edge of this view. What we're able to do, and I'm going to get in this in the next slide, is I'm actually able to take that warped image. I understand the azimuth, or thus the rate of change. I can then reverse that, digitally speaking, within an interface, and then we can create just a normal looking image that is like a normal security camera, fixed security camera image from that warp view. So let's go ahead and talk about that. So what's cool about this is when you deploy a fisheye, it can see all the way around itself. So typically when we're talking about deploying surveillance applications, we like to have overlapping fields of view. But that obviously is going to be costly. You need another camera, you need another drop, that's more installation. And I guess if you think about it, it's more things to maintain, more things to break. This one 360 camera, you can deploy it in a general area. I would say when you're thinking about deploying a 360 camera, you want to think about it in terms of surveilling a confined space. These obviously cameras can see forever, right? But the amount of pixels on target or the resolution you can gain over the distance decreases dramatically. So when I think about deploying a 360 camera, I like to keep it within about a 25 foot radius from where the camera is. So it can basically surveil like a 50 by 50 square foot area. If we think about that. I would also mention that having the overlapping fields of view is actually kind of nice from a security standpoint, because if we're filming, if an event occurs, we actually have two different perspectives, whereas the fisheye will have a single perspective. So again, something to consider when you're deploying it. What's really, really cool with our fisheyes is we sort of combine the functionality of a PTZ and a fisheye. So we can perform this function. It's going to be called an ePTZ function, or electronic PTZ. And essentially, since we are recording the circular full image, and what we're doing is in our client, we are just taking that image, right, and we are manipulating it. We are dewarping it in real time. So what is being recorded is that circular image, but you can take that image and you can dewarp it, right? And when it is dewarped, you can actually maneuver around by dragging and clicking within our interface, kind of like you're inside of a bowl, if you will. And you can, in real time, manipulate it just as you would a PTZ and reorient your field of view. And what's really cool about this is that we only charge you a single subscription, which, by the way, we have a subscription model. So the amount of cameras that you attach to our cloud infrastructure will dictate sort of the subscription cost, right? Every camera is going to have its own individual subscription. What's interesting about this is you use one subscription and you can spool up as many little dewarp views as you want that, again, are fully manipulatable. And we don't charge you extra for the extra streams that you spool up. A lot of other VMSs, they will charge you per stream that you're using. Since we're essentially just manipulating data that we're already writing, we don't really require that. And the cool thing too is, again, the amount of coverage you can obtain with the fisheye is pretty extraordinary. I would make the point that you want to deploy these things in open areas. You obviously don't want something obstructing the fisheye, especially really close to it, because you're going to obstruct everything behind it. But given that you can deploy this in a wide open area, you're going to have a very significant amount of coverage. Again, it's going to be a good force multiplier just by deploying this single device out in the wild to perform your general surveillance needs. So what do we want to consider when we're choosing a camera? The first and foremost thing that comes to my mind is going to be the lighting. What is going to be the lighting, when in that field of view of what we're looking at? Is it going to be low light, right? Is it going to be is it going to be really, really low light during nighttime, right? Are we going to have to use IR illuminators? Are we looking at the front of a store, like a big glass storefront where it's, facing east? And so at some point we're going to have sun directly flooding in there. Lighting, a camera's ability to deal with either high or low light is sort of its grade of its performance, right? And so that's when I think of a camera, that's what I think about if I think about a high performance camera, is that it is able to span both those unique sort of scenarios and ascertain the best fidelity color image possible. And I touched upon this previously, this idea of obtaining a color image in both very high and low light scenarios, is that if you think about it, color is a very good forensic detail. If someone goes to my store and they're in the parking lot and they do a smash and grab and I have a black and white image and I can't tell the cop, while they're looking for the person 30 minutes later, what color the car is, the cop's going to have a harder time doing his job. It's the same thing if we have an active shooter situation, if we have an active theft situation, our ability to give the authorities or the powers that be that type of extra detail is going to make their jobs much easier, and they'll be much more effective. So we want to think of deploying cameras to optimally grab color imagery at all times of the day and during those sort of natural lighting circumstances given their application. And so there's two different factors. The first factor to consider is going to be its low light color reproduction. This is a lux factor, how low of it can produce a color image at a certain low lighting circumstance. And then there's also this idea of WDR, or wide dynamic range. And this is a camera's ability to deal with varying degrees of dynamic light, typically differing in intensities throughout the same field of view. So, I mean, literally, I could go on, I could do an hour presentation on just those two things alone, but that's a very important concept. And again, the mark of a good a surveillance camera is that it can do both those quite well. The other thing you're going to want to take into consideration is the surface that you're going to mount it on. And really, that's kind of the placement of the camera itself. Certain surfaces require certain mounting hardware. They also will dictate how hard it is to run a cable there. Obviously, every one of these cameras needs a single network cable to power it and to send the data back to our recorder. But different surfaces, it's harder to drill through a brick surface than it is a drywall surface, right? It's harder to get to a hardcap ceiling with no raceway or cavity behind it, and so it's going to increase potentially the install cost, but it's also going to dictate the type of mounting hardware and obviously the field of view of what it's looking at. So just consider that. I mean, we want to, if at all possible, try to make sure that our camera placement is going to be conducive to installing these as easily as possible. Otherwise, we're going to be ending up driving up the install cost of these deployments. How far, how wide the camera field of view will be. This goes back to initially the cameras, right? The type of cameras. Cameras come in essentially two different types: fixed cameras where they have a fixed focal length, and varifocal cameras where they actually can have different types of focal lengths and therefore different types of zoom properties and different fields of view. And so, fixed cameras are going to typically be more affordable than varifocal cameras. Varifocal cameras are going to be more versatile as far as when we deploy them, we can set their fields of view. But we're going to want to know that if we're going to want a camera looking at an egress point or an ingress point, like the front of a store, and we want to capture all the faces, we want to make sure we're using a camera where we can tighten that field of view to just the right and left extremes of a door. That allows us to get more pixels on target and therefore have a better forensic experience as far as the data that we're capturing, particularly in like a facial detection scenario. What is the recording resolution that we need? This actually dictates a lot of stuff. This will affect the amount of hardware that will be needed on site. This will affect the subscription cost in our case, because we do bill based off of the resolution of recording and the duration of recording for. But this is, and it also, it'll speak to essentially this idea of we want to refer to it as levels of resolution. As far as a good application of what you're trying to get. I'll go ahead and explain this a little bit more. So in the surveillance world, we think about resolution in three different ways, right? The first way is this idea of detection. It's the amount of resolution that's required for you to detect an object at a certain distance. And this requires, not too many pixels. You can get away with like 8 to 10 pixels per horizontal foot, right? But think about it in terms of, if I'm looking at the surveillance camera, if I see something out in the distance, I can sort of discern what it is, whether it's like a human or a vehicle. That's sort of the level of detection as far as that resolution. The next level is going to be recognition. And this is the amount of resolutions that's required, that if something was to happen, or a person was to be present, or a car was there, or a scene was to fold out, you could take that scene and you could give it to someone who knows the person or the car, or is familiar with the business, and they could recognize things about that, the person, the car, what's going on within the business. So it's this level of being able to have an associate view that data, and then basically be able to extrapolate more simply based off of their experience, with the scene, the person, the car, right? And then we have this last level of resolution, and it's the idea of identification, and it's the highest level of resolution, right? So the idea here is it's enough resolution where I can give this to someone who has no idea what's going on, has never seen these persons, never seen this car, doesn't know this business, and they are able to properly identify people. And so when you think of creating a surveillance solution in the terms of how effective it's going to be, we want to think about detection, recognition, identification. Think about those specific fields of view that are important to you and what level of resolution you want. And then really your integrator can just do the math. All those essentially, all that comes out to is we need to get a certain amount of pixels on target. And so we just need to know the distance to that target, and therefore that's going to resolve the resolution we need to build a proper surveillance. So don't think about, I need a 4 megapixel, I need a 3 megapixel, I need a 4K camera. Think about it as, I need to detect something here, I need to recognize something here, I need to identify something here, and that's going to get you a much better solution. This idea of weatherproofing, we talked about it before. It's this idea of an ingress rating or an IP rating. Your phones have a similar type of rating, right? You can dunk your phone in water. Right? Some phones you can, some phones you can't. It's the exact same thing with surveillance cameras. I would say the vast majority of cameras have like a minimum IP rating. It's called IP66. This is water and dust egress protection. Eventually, what that means is you can deploy this thing outside and it can be rained on. That's fine. It can't be submerged. We then move up to IP67 and IP68. The camera I was talking about that was submerged for a week is an IP68, which means that it is positively pressurized inside the camera body, and thus it pushes any sort of potential moisture that can get into it outward from the camera body. But know if you're going to need weatherproof cameras. There are technically indoor camera only, right? And so these don't have the moisture protection. They will have dust protection. They have like O-rings on their bodies, but make sure that we're not putting an indoor camera outdoor. This idea of a vandal rating too. Vandal rating, we measure the rating of a camera by whether or not it can be survived, or it can survive a direct impact from a baseball bat. Right. So that's called an IK10 rating. I think that's actually kind of funny, but it makes a lot of sense. Obviously, if you can survive a baseball bat, you can, it's a pretty durable camera. Technically, if anyone is interested, that means it's 25 kilojoules per square inch on the camera. That's a baseball bat strike. But knowing if you need a vandal-proof camera, there's obviously applications here that's going to be that's going to be a good thing to have, like in a school. Like kids just, they like to break crap and screw with stuff. So it's going to be a good idea to have a camera that's kind of durable if we're going to be deploying in those types of environments. Obviously, like justice, or what am I trying to say? Like prisons and those types of institutions obviously would benefit from a vandal rating. And then the last thing we want to talk about is if we're going to use an analytic. I sort of touched upon this earlier, but think about an analytic. If I have a field of view, I can essentially specify a virtual region of interest. And if someone goes from the field of view into that region of interest, I can then send notifications and perform certain actions. And so with that said, the way that we set up a camera in its field of view, we want that to be conducive so we're able to detect things more accurately. There's certain ways that you can deploy a camera where analytics are just not going to be very accurate. They're not going to work very well at all. And so what we want to think about is if we're going to deploy an analytic, we want to do that and take that in consideration during the design process. So we're placing that camera so it is conducive of getting the most accurate analytic readings. So a lot of specs, if you look at a camera data sheet, you're going to see all these things, resolution, frame rate quality, if they have specific application, and then obviously the lighting capabilities of it. Again, we covered resolution. We want to think of that in terms of detection, recognition, and identification. Don't get caught up with wanting to get the highest resolution camera all the time. It's not necessary. And it can also be cost prohibitive. You can really value engineer a solution if we just, use the appropriate amount of resolution per the application. Okay. The frame rate and quality, this is going to be really important. Sometimes you're going to need a higher frame rate camera, right? If we're doing license plate recognition and we're trying to recognize license plate on a toll road where cars are going 80 miles per hour, we're going to need a higher frame rate. We're also going to need a higher shutter speed, but we need to take that into consideration. The vast majority of normal surveillance applications, if we're at a small business and we just want to surveil a parking lot, you don't need a high frame rate. If you look at a movie runs at 24 frames a second. You can actually bring that down to between 12 and 15 frames a second. And it's really not discernible between that and a movie, right? That we can't really make out very much more after we go up to about 12 to 15 frames a second. And then really what happens is when you get really fast moving objects within your fields of view, they begin to blur. And again, that's just because we need to produce more frames. We also need to increase the shutter speed as well. But taking that into consideration, like if we're trying to monitor fast moving targets, we want to probably think about if we're going to use a higher frame rate. Obviously, the application where it's going to be placed, is it an exceptionally rainy application? Are we going to be close to the ocean and we need to maybe go with a stainless steel option because of corrosion issues, right? Are we going to be in a caustic environment inside a chemical plant, right? Figure out the application just so we can take into consideration different types of environmental considerations, right? And we can then pick the proper camera. And then this is the big one. Again, it's the lighting. It's the lighting and the WDR property of the camera. Make sure that is fit. It's going to be fit for the application, right? If we do need to have, we want to figure out what color cars are in a parking lot and there's no light poles out there. We're probably going to want to use, an exceptionally low light camera. Sometimes that can be very costly. It might just be better to actually install like an illumination device on the side of a building, like an LED illuminator or something like that, to just supplement the light. So just take all these in consideration. If you look at every camera, they all have data sheets and they all talk about every one of these points here. So from a general perspective, the entrances, the egress and the ingress points where people are coming in and out of the business, putting a camera there is great. You get basically good detail of people's faces, what they're wearing. And then you can essentially have cameras that have more general view of larger areas, and you can sort of, what that person looks like. You already have all these details. So as they move around and do stuff, you don't need to get facial detection constantly, right? Throughout the entire fields of view of all your cameras. Important places where transactions are done, obviously cash registers where money is exchanged. Want to probably surveil those types of things. Low visibility areas, so if you're in a retail environment and you're the manager and you're the only one there and you're checking someone out and there's a bunch of blind spots behind some sort of racks with clothes on them, you might want to have a surveillance camera out there, so while you're checking someone out, you can actually look at the live view and see if someone's doing anything fishy back there. Obviously, storage where you have product and you want to monitor that product to make sure that there's no shortage issues that are occurring. Employee theft is actually the primary means of shortage. Employees steal more stuff than customers do. So obviously being able to monitor your product, that's where you're generating your money. Big open areas, those are easy to surveil. You can just put a wide angle camera down there, even a fisheye. Hallways and staircases, these are great places because they have natural choke points, right? People got to go in and out of hallways. They're long. So you can basically put a camera at one end of the hallway and someone's got to approach that camera. That means you can it's a long time for them to be in a camera shot. You can gain a lot of details, and as they get closer, there'll be obviously a higher resolution. Parking lots, fights, theft, tons of stuff obviously happens in parking lots. They have their own kind of unique use case because parking lots can be quite big. So sometimes you're going to have to use, multiple cameras instead of just one. So taking that into consideration. And then obviously where there could be potential for, dangerous things, where people have to follow certain safety rules, right? Or if there's some piece of safety equipment or there's an area where people should not be, putting a camera there to essentially mitigate risk and to, also monitor people and make sure that whether or not they have good habits and stuff like that. But the biggest thing, and we talked about this previously, is you guys know your business better than anyone. Your integrator, again, they're experienced. They know how to hang a camera and set up a system, but their business is the surveillance business. So they're going to give you sort of a a level of general surveillance, you will know better than anyone where your blind spots are, where your trouble spots are, where the high value stuff is within your business, all of that. So it's really a combination of you and your integrator putting your heads together and coming up with the most effective solution. That's the best way to think about this. And let's just talk about real quickly analytics. So we have 5 different analytics that are baked into our platform: line crossing, people counting, camera tampering, loitering, and intrusion detection. Again, the idea here is pretty much any camera, okay, because we support a whole bunch of cameras. Any camera can essentially use analytics. You can activate them on the fly. You literally just press a radio button. You go into a configuration screen. You set that virtual region for a line cross, for a people counter camera. And then you set up the parameters. You set the target size, and then you just save that thing, and it's a set it and forget it type thing. You can obviously set up notifications and alerts. So, if we want to be notified after hours if someone is going dumpster diving or something like that, I can use like a loitering analytic. And if someone stays next to my dumpster for a long period of time, I can then send a notification. So these are really, really cool. They can be applied after the fact. I spoke about this earlier. We want to make sure that if we're going to be using an analytic, we should decide that before we deploy a camera. So when we do, it'll be in the most effective position possible. But we offer all of these analytics. You can do them on HDTVI solutions. You can do them on analog cameras. You can do them on IP cameras. And again, you activate them on the fly. And, let's talk about the cloud surveillance, the platform, as far as, a way to maximize your budget and to keep costs down. Like, the first thing that we want to consider is we work with essentially all IP cameras, almost all of them. I would say 95% of them. Our interoperability standard is based off of ONVIF. And basically all cameras nowadays, especially all modern cameras, almost all of them apply to this ONVIF standards, which means that we can work with all your cameras, which means that if you have an existing camera deployment, we can work with that deployment. If you have an existing analog deployment, maybe we're not even at IP yet, we have IP. We have the ability to take analog cameras directly into one of our on-prem devices. We can also migrate to a higher resolution solution while keeping the same infrastructure, the coax infrastructure that you would use with analog. I can actually produce a higher resolution stream through that existing infrastructure that can be up to 64 times the resolution. I can actually go up to 4K with some of those, and that can be even more cost effective. Thinking about saving money when deploying fisheyes or using one of these cameras that is a force multiplier that can get multiple fields of view, that we can spool up multiple streams free of charge. Deploying one camera instead of 5 is going to decrease the amount of install, the amount of device costs, and the amount of subscriptions that you'll have to use. Reducing IT cost, moving to a video software as a solution. So we're a service provider. Our service is our VMS platform. And with that said, we do a lot of very high level centralization of a lot of VMS features just baked into our most affordable subscription. That alone, that's an hour-long presentation. We can talk about all the really cool things that we do. So I encourage everyone to, reach out to us, and we'd be more than happy to do a demo and do a presentation on just the platform alone. And then also, being able to use analytics as a force multiplier. So make an ordinary camera sort of extraordinary, if you will, by the use of analytics that, again, you can just dynamically spool up. As far as the cloud VMS, broad camera support, I talked about that. We use ONVIF. We can also use other mixed technologies, so we can create hybrid solutions. We can actually have more advanced analytics as well. So the whole cloud video system is built upon an API. It's essentially the engine that allows us to transmit data to the cloud and manage it. We can actually work with really advanced third-party systems like other cloud companies that do video analysis, and we can send them the data. They can send us the data back. And we can actually create an even more robust solutions with very, very advanced analytics. And so that's based off of our API platform. It's free to access. If you have subscription with us, we give you full access to our API and all the functionalities. And that sort of brings me to my last point, is that this REST-based API is really, really important, and it gives us the flexibility to do all these really great VMS functions within a web interface, and work with a lot of other third parties in a cloud-to-cloud integration. We don't have to worry about running wires at the site, right, to run an integration or doing serial connections or network connections. Everything, once the data is in the internet, we can share it with other data or other services that are in the internet. And it brings me to, I guess, my next point is that we have some other companies that we work with, such as Brevo. We do cloud video surveillance. Brevo does cloud access control, right? So they have a whole a card access system that is built into the cloud. This is, again, our sister company. We have a really robust free integration that allows us to associate activity at doors and with devices with the video of cameras that are looking at those devices at that time. As free integration, this is a great way to create a more a complete low voltage physical security solution. And then we also have another company. This is Swift Sensors, and Swift Sensors is a industrial control sensor company, right? So they have all these different types of industrial wireless sensors, anywhere from pressure sensors to flood sensors to static shock sensors and everything in between. This is a cloud-based solution, so you're able to gather real-time data from those sensors in a cloud interface. And again, it's one of our sort of sister cousin companies. I don't know what we want to refer to it as, but we do have some really great integrations to associate videos with that sensor activity. And with that said, I'm going to go ahead and hand it back. I think we'll do a little Q&A. But thank you, everyone, for listening to me. I hope it was informative, and I did go over time, so I apologize. And I'll shut up now.
Thank you so much, Matt. It was a really informative overview. Thank you very much. And everyone, thanks for sticking with us. We appreciate you being here. We're going to take some time to open the floor to any questions that you might have from the audience. We actually already have quite a few questions that have come through, so maybe we could do kind of a speed round, Matt, and see how many questions that we can answer, because they're all very, very great questions. Okay.
All right.
So we're going to start off with one of the first few questions is, in a small office, and we're thinking about 15 foot by 25 foot, would using a bullet camera or a mini dome be more reasonable, would you say?
Well, you know, it's sort of personal preference, honestly. I think one of the things I didn't get to mention is a lot of camera companies nowadays, they essentially use the same sort of guts, if you will. All cameras, their processing and performance are based off of this idea of a system on chip. It's called a SoC. It's actually the same thing that runs your cell phone. And what companies do is they actually apply that to essentially a line of cameras, different form factors, but they have the same guts, the same resolution, the same type of performance factors like low light and WDR, performance. And they do that because nowadays there are very few differences between, a bullet in a dome or a mini dome or a micro bullet or whatever it may be. It really comes down to personal preference. So maybe you want the camera to be more visible, right? So a bullet would be okay. Maybe you want it to be a little, innocuous and people don't see that. So maybe a smaller form factor like a micro dome would be good. But essentially you can get the same performance out of both those form factors. I would make the point that if you're talking about a small confined space, a fisheye might actually be a really good application as well.
All right, thank you. And then we had another one, which is mounting height an issue? And I think this one was specific to the fisheye camera slide.
Yeah, actually, that is a great point. I completely, even in our trial runs, I forgot to mention this. Yeah, mounting height is going to be is something to consider. You typically want to mount fisheye cameras anywhere from, I would say, 12 to 14 feet on a ceiling, right? Once you go higher than that, your perspective gets a little bit skewed. Again, the farther away a target is from that camera, the less resolution, less pixels we can get on target. So I think the optimal mounting height would be around 12 to 14 feet on a ceiling in the center of a room.
Okay, that sounds great. And then what is the accuracy of our people counter analytic? And also someone had the question of, can it work in conjunction with access control?
Okay, so as far as the people counting analytic, its accuracy is going to be based off of the placement of the camera. So we can ratchet up the accuracy to be very, very high, given that we place it essentially directly above like an entrance point, and we want to funnel people through like a slight pathway. So we have retail customers. I can think of one that's a jewelry customer, and they actually have like those velvet ropes right when you go into the entrance, and they actually funnel people, and they put the people counting line in the center of that rope, and so it acts as a natural funnel, and they have a high degree of accuracy. As far as associating it with access control, so obviously we can associate like the video with access control, like with Brevo, we can do a cloud to cloud integration. Typically when you associate any sort of VMS or video platform with access control, you're really just using the sensor inputs from the access control system, and you're pulling data, at that time from the video system that's looking at wherever those devices are. I think if you could maybe qualify your answer or your question a little bit as far as like what you're trying to do by associating the counting with the access control. But obviously, we can associate video and access control data very easily.
Okay, thank you. And this question is, why in your opinion is the difference between using an analog camera and hybrid camera or an IP-based camera for surveillance operations?
What are the benefits, or why are they better?
The difference of using one over the other.
Well, okay. Well, so analog cameras, that's the oldest technology sort of on the market. Believe it or not, though, the vast majority of existing deployments still use analog. Analog has a maximum resolution, essentially, right? So we can only go to a certain resolution. And when we want to go into higher resolutions, that's typically where the IP camera came into play. The IP camera, by virtue of having sort of this onboard processor, can produce higher resolution imagery. But we've now gotten to the point where we're using, I think you're referring to that as like a hybrid camera, but it's this camera that utilizes the technology, and from an industry perspective, we refer to this as H2 over coax, but it's the ability to use existing coax infrastructure, which would be there for analog deployments. IP deployments use network cable. So analog, it's going to use analog cable. It actually, if you replace the device on either end of that cable, the coax cable, these H2 over coax solutions allow you to operate at IP level resolutions while actually still keeping some of the interesting qualities of an analog camera. So IP cameras, they're network addressable devices, and so they're subject to network phenomenon such as packet collision, packet loss, data prioritization. Where an analog, it's just a signal, right? And the signal is just raw. And when it gets to a DVR, it's processed there. So what you end up getting is with an analog, you actually get full frame rate, and it's incredibly smooth, right? And here's another cool thing: it's actually not even encoded, right? An IP camera is actually an encoding device. It's compressing the data at the camera level, and it's sending it down a network cable to be written on a disk. It compresses it at the camera because it allows it to occupy less space on the network and less space on the disk, right? So it's there by design. Analog camera does that at the end, at the recorder level. And so what that allows us to do is that gives us a really great, pure, smooth, high frame rate stream that you don't get with IP. Well, when you go to this HD over coax solution, you merge the best of the qualities of both those cameras, right? You merge high resolution and really smooth frame rate. And so the world is your oyster. The technology that we have out nowadays allows you to be incredibly flexible with whatever you're trying to deploy. And again, we work with all these different technologies. So we can act as that hybrid system that merges all those things into a single pane of glass on our interface.
All right. Well, we do have quite a few questions, but I think that's all we're going to be able to take for now, since we're coming close up on the hour here. But we did have a few other questions regarding camera specifics, also camera resolutions, and making sure that they're compatible with our system. So with that, I would go ahead and say, go ahead and connect with us. Give us a call, send us an email. We are highly, highly responsive, and we're really eager to have a personalized demo with you. We also have a live chat on our EEN.com website page where you can immediately get answers to your questions, but we will also personally follow up with you. We'll be sending, check your email. After this webinar, we'll be sending the recording of this, and we'll also make sure to get back to all the individual questions, and we'll also provide some further reading material for you all regarding this subject. So we look forward to hearing from you. Thank you so much, Matt, for being our presenter today.
You're very welcome, and thank you everyone for bearing with me. I do appreciate it.
Thank you, everyone. All right, look forward to hearing from you soon.